Welcome to the 2022 Revision Support for Learners, Higher Maths. I'm Leah Payne from McLaren High School in Callander in Stirling, and I'm going to take you through the updated guidance from the SQA to help prepare you for your exam in May. So the purpose of this session is to become familiar with the SQA guidance for the 2022 exam, to identify useful revision resources, and to consider top tips for exam success. By the end of the session, you'll be able to use the SQA guidance for the 2022 exam to help you plan your revision and to prepare you for the final exam itself. So thinking about the Higher Maths exam, okay, when is it? Well, it's going to be on Friday, the 6th of May in the morning. Paper 1, which is going to be non-calculator, is going to start around 9 o'clock, finishing at 10:15. Paper 2 will be about half an hour later, starting at 10:45 and finishing around 12:15. So I say around these times because different schools may have to adjust slightly their start and their end times just due to their school day with their breaks and things like that. What will the actual paper itself look like? Well, it'll be paper 1, which is your non-calculator, 55 marks, 1 hour and 15 minutes to complete that. Paper 2, your calculator part, will be 65 marks and you will have 1 hour and 30 minutes to complete that. So a wee bit longer for paper 2, but it is worth more marks. Now, on the week beginning of the 7th of March, the SQA published some guidance for subjects about what will be assessed and what will not, or more so what will not be assessed in the 22 maths exam. Okay, so not just the maths exam for your other subjects as well, but we will just focus on the higher maths within this session. So at the top of that list, we have got vectors and recurrence relations. So those were two subjects, or two topics rather, that were always out. So at the beginning of August, we knew that we weren't to kind of spend too long on these areas, okay, because they wouldn't be assessed in the final exam in May. So starting from the third kind of point here, this was the new information that was given out the week beginning the 7th of March. So we'll just run through that just now. So firstly, sketching the graph of a differentiated function given the graph of a function. Finding the coordinates of the point or the points of the intersection of two curves. Solving for a and b an equation of the form y equals a times x to the power of b, given two pairs of corresponding values of x and y. Sketching the graph of the inverse of a log or an exponential function. Using differentiation to determine the equation of a tangent to a curve at a given point. Using differentiation to determine the stationary points of an algebraic function, and then sketching the graph of the function with all important features identified on the graph. Solving any problems containing the phrase rate of change. Integrating a function of the form x plus q to the power of n. Integrating any trig function. Finding the area between two curves, and finally proving any trig identity. So this was the list that was published by the SQA the week beginning the 7th of March to give us an indication of topics that were not going to be assessed in the final exam. So having a wee look at the guidance in more detail, Cleland Maths on YouTube has put together a really useful video explaining the updates from the SQA about the 22 exams. So I'm going to let this play and hopefully you will get something from it.
Mr. Cleland here from Cleland Maths. Today we're going to be looking at the Higher Maths 2022 exam changes. Quite a lot to get through, so stay with me. Okay, let's start with algebraic and trigonometric skills. So the first thing on this page, we've got manipulating algebraic expressions, manipulating trigonometric expressions. You will need to know trigonometric identities, but you won't have to prove trigonometric identities, which implies probably you won't have to use trigonometric identities to prove anything. But essentially, you're not going to be proving trigonometric identities. Next page, we've got identifying and sketching graphs of related functions and composite and inverse. Well, big one here. You don't have to sketch the graph of a derivative given the graph y equals f of x. You don't have to sketch the inverse of a log or exponential function. Everything else is still in. On the next page, we're on solving algebraic equations. Quite a big one, this one. If we look down near the middle, it says solving equations of the following forms for a and b given pairs of x and y. And they're log graphs. Log y equals b log x plus log a. Log y equals x log b plus log a. Those types of equations where they're turned into almost straight lines are gone. But you might have to use a straight line to confirm that it is indeed an exponential graph still. So be careful there that you don't get mixed up between the two. But that's gone. And finding the points of intersection, well, you'd have to do it between a straight line and a curve, but between two curves, a little bit harder skill, that is gone. Solving trigonometric equations, that's still in, not an issue there. So you'll have to use the wave function, trigonometric formula, all the identities over a given interval. Okay, let's look at geometric skills next. So we've got vectors, and we've never had vectors back in, so all the vectors are still out, still gone. Not an issue there. Calculus skills, that's differentiation and integration to me and you. So, let's go back a little bit on that. Determine the equation of a tangent of a curve by differentiation, that's gone. So, if you've got a curve, and you'll not have to find the equation of the tangent to the curve at a given point. That's quite a big one, that's quite a common question. What is the equation of the tangent? You would usually have to differentiate it, find the gradient at that point, and then substitute in y minus b equals mx minus a. So that's gone. You'll still have to use the stationary points to find out if a function is increasing or decreasing, but you'll not have to sketch a graph of an algebraic function by determining stationary points and their nature. Integrating functions. If you look at our integrating functions here, we've still got to integrate x plus q to the power of n, but anything to do with trigonometry will not be integrating trig, and will not be doing integration of px plus q to the n, which is quite a difficult one to do. So that's gone, and that is gone, leaving just integration of the form x plus q to the n, or solving differential equations. The next thing, differentiation, we have got anything to do with rate of change. If it mentions rate of change, it's not going to mention it in this exam, so you don't have to remember that rate of change means differentiation for this year. It's gone. Also, what's gone will be finding the area between two curves. You still have to find the area between a straight line and a curve, but two curves is gone. That's gone just because of rate of change. Okay, algebraic and geometric skills. So we've got all our usual straight line stuff, perpendicular lines, knowing that the gradient is tan theta, properties of medians, altitudes, perpendicular bisectors, equations of circles, tangents to circles, intersections of circles and line, that's all still there. The bottom bit's always been out for a while, recurrence relationships. So that's the only thing on this page that I am crossing out. Okay, reasoning skills. There's nothing really there. This is just part of the normal SQA thing where you have to adapt and apply. There's nothing particular gone from there. And obviously you still need to know your symbols that might be used in any given question, natural numbers, whole numbers, integers, rational numbers, real numbers. Although you don't have to use them in your actual answers yourself. Okay, let's summarise and let's go through what's actually just in then and ignore what's out. What should you study? What should you revise? Let's go. Quite a big bit this, bear with me. This is from the Zeta Maths. Straight line, most stuff with straight lines in, all your stuff from National 5 should be skills that you already know, how to find the gradient, how to find the point of intersection between two lines, and from higher, midpoint, gradients, perpendicular lines, knowing that m equals tan theta, collinearity, perpendicular bisectors, medians and altitudes, all that's still in. And then these are the common terms you should know for straight line stuff. Let's move on to quadratic functions. Stuff from National 5 is there. You should know completed square form, factorised form, expanded form. You should be able to, from completed square form or root form, find the turning point, substitute the other point to find the value of k. You should be able to solve quadratics in any which way you can. You should be able to sketch quadratics from completed square or root form. You should be able to determine the nature of the roots and use that information to state what the nature of the roots are. You should be able to solve quadratics by rearranging and by completing the square. You should be able to complete the square when there's non-unitary x squared, so 2x squared, 3x squared, 5x squared. Solve quadratic inequalities, and you should be able to use the discriminant. You should also be able to show that a line is a tangent to a curve. You don't need to find the equation of a tangent to a curve, but you should be able to show it as a tangent. And you should be able to know the nature of intersection between a line and a curve. Also, you should be able to find the points of intersection between a line and a curve as well. Okay, the circle, standard stuff, equation of a circle, the distance formula to find the radius, being able to find the centre and the radius and therefore the equation. All the circle stuff that you already know about is in. There's your intersection of two circles there, equation of a tangent to a circle. That's an interesting one. So, although you have to find the equation of a tangent to a curve, a circle is not a curve, a circle is a circle. So, equation of a tangent to a circle, different skill, is still in. Be careful there. Okay, common words for circles. Functions, stating the domain and range, all still there. Composite functions, inverse functions is still in, although you won't have to sketch a graph of an inverse log or exponential. Your common notation for that is there. For sets, graphs of related functions is all in. Add vertical and horizontal translations, reflections, and so on. Polynomials. You'll have to factorise polynomials, synthetic division is still in, solving polynomial equations, finding the remainder, finding unknown coefficients, finding the equation of a polynomial from its graph is still in. Trigonometric functions. Most of the trigonometric stuff from National 5 is there. Exact values you should know. Point of intersection between a graph and a line. You should know the addition formulas and how to use them in double angle formulas. The wave function's still in. You've got sketching graphs, maximum, minimum values. And then we're moving into indices and differentiation. Increasing and decreasing functions. Finding stationary points in their nature. Optimization, closed intervals. Basic integration still there. Definite integrals, area under curves, all the usual stuff, differential equations. Chain rule is still in with differentiation. Differentiating trig, but not integrating trig. Log rules, log equations, sketching related graphs, evaluating expressions using rules of logs, exponential growth and decay, and that's as we're done. Mr. Clown here.
So that was quite a lot of information that David Cleland on Cleland Maths had run through there, but very useful information to help prepare you for the exam. So let's have a wee look at some other revision resources. So if I click on the higher past paper checklist, the people version, this is what it is going to bring up here. So what we have got is a checklist. This is a really useful tool. So it's just brought up all of your past paper questions, papers from 2019 to 2015, okay? And people at Wallace High School have very kindly put them into topic order, okay? And they've greyed out the topics that are no longer going to be assessed in your final exam this year. So it is hoped that pupils would make a copy of this, right, just as a revision guide, and then they would just work through it, and you can tick it once you have completed that question and you feel confident within that question. So all the papers are hyperlinked there, okay, so you just have to hover over the year, and then the link comes up and you can click on it. The solutions are also there. Right, you can click on that. It's a good idea to get into the habit of looking at the SQA marking schemes, the solutions, so that you can see where the marks are being awarded, okay, and you can try and pick up some more marks. Right, so it's got the non-calculator stuff at the upper half, and then it's got the non-calculator at the bottom. So you would just make a copy of that, it would save into your Google Drive, and you'll be able to update it as part of your revision. So let's have a wee look at some past paper questions from that sheet. So having a wee look at the SQA 2019 paper 1 first of all, okay, and the question is asking you to find the x coordinates of the stationary points on the curve with the equation y equals a half of x to the power of 4 take away 2x cubed plus 6. So I'll let you pause the video and you can try it, and then press play to see if we have worked in the same way to get the same answer. Okay, so here is your solution. So they're asking to find the x coordinates. So basically you want to have to solve this for x for the stationary points on the curve. Okay, so just the kind of language in the question, it is telling you to differentiate. So we'd obviously have to check that it is of a differentiable form, which it is. Okay, there's no powers or anything to sort out. So we just have to take the terms individually. So the 4 comes down to multiply the half, and what we get is 2. X, we knock 1 off the power to get 3, so 2x cubed. Take away, so the next term, the 3 comes down to multiply the 2, so we get 6x, and we knock 1 off the power, so 6x squared, and then the plus 6 just disappears. Okay, so then try and allow yourself thinking time to think, right? What is the next step in the process? Well, statements are good. Let dy by dx equal 0 for SPs. Okay, so tell us why you're doing these things. So we can say 2x cubed take away 6x squared is equal to 0. So now that it's equal to 0, right, we need to solve it for x, so we have to factorise. Is there a common factor? Yes, there is, 2x squared. Okay, so that comes outside the brackets, and inside the brackets goes x minus 3. And that's equal to 0. Okay, so then x is equal to 0 and x is equal to 3. And you can just underline your final answers. A good idea also to go back and just read the question, find the x coordinates of the stationary points in the curve with equation. Yep, that's what I've done. I've got my x values, and that's me finished, completed that question. So thinking about where the marks are going to come from, right? Possibly for differentiating your function. Okay, so mark number 1, letting it equal to 0, for factorising it, and then for your 2 remaining solutions. Okay, right, moving on, and we'll have a wee look at the 2018 paper 1. So this is question number 11. So again, if you want to work through this at the same time, then pause the video now and then press play once you think you are done. Right, so question number 11, the diagram shows the curve with equation y equals log to the base 3 of x. On the diagram in your answer booklet, sketch the curve with equation y equals 1 minus log to the base 3 of x. So because you're just revising, I would suggest that you copy this graph out, okay, because you can then pop it on the diagram. So let's have a wee look at that equation, right? And it is y is equal to 1 minus your function being log to the base 3 of x. So it's a good idea to rearrange so that your function part is at the beginning, right? So I've just rearranged it, it's the same thing. My log to the base 3 of x is still negative, my 1 is still positive, but I've just written it in a different order and it just helps. So if on the graph, I want the graph of just this bit here first of all, so I'm just going to ignore the plus 1. Okay, what the minus means is that you are reflecting it in the x-axis. So that coordinate point there, so it's always to do with the coordinate points, that coordinate point is going to stay there, but the second coordinate point is going to reflect in the x-axis, so it's going to be down here somewhere. And we would annotate it and we'd say that that's 3 minus 1. So don't try and draw the curve first. Think about your coordinate points and get them sorted out. Okay? So then what we have is a graph that kind of mirrors that one up there. So I'm just going to sort that slightly, but you get the gist. So that is the graph of y equals minus log to the base 3 of x. Okay? So the next thing that we want to deal with is the whole of that, right? So the minus log to the base 3 of x plus 1. So it's just taking your new coordinate points and adding on 1. So remember what happens, that pushes the graph up by 1. Okay, so you're going to have 1, 1 there. So annotate it, and then it's the blue one, remember, it's going to sit on the x-axis. So you can either write 3, 0, or you can just show that it's there. And it's going to cut through that point. So you've got the graph of y equals log 1 minus log to the base 3 of x. Okay, so that's what you've done for 2 marks. Now, part B on the question says, determine the exact value of the x-coordinate of the point of intersection of the two curves. So what they're asking for is this bit here. So we're not interested in the blue one because the blue one was just drawn just to help us get the correct translation for that next one. So all that we do is we just let y equal y, and that's what you always do for points of intersection. Let y equal y, you let one function equal another. So you've got log to the base 3 of x, and that is equal to 1 minus log to the base 3 of x, right? So depending on how you see this will depend on how you go about solving it, okay? You might notice that you could just take that minus log to the base 3 of x to the other side, so you'd be left with 2 log to the base 3 of x is equal to 1. Okay, so I've just taken that minus 1 over to the other side, so it's minus on that side, it'll get added on to there, so that's why I got 2 log to the base 3 of x. Now, we can only sort logs if we have got logs on both sides, so log to the base 3 of 3. Okay, so 1 times that, so we end up with log to the base 3 of x squared, and that is equal to log to the base 3 of 3, because you've actually got 3 to the power of 1, which just makes you 3. So at that point, you can take the log to the base 3 off at both sides, and we have got x squared is equal to 3. Okay, so then we just want to work out the value of x on its own. Doing the opposite of a square is the square root. Should really get a plus or a minus 3. But if you write it like that, remember you're going to have to make the statement that therefore x is just equal to positive root 3 because, right, you can see that the x value is a positive value at that point there. Okay, so that is your final solution. You've got x is equal to root 3. Okay, so then what you would go back and do, so that's me looked at a couple of questions on these past papers, okay, from that grid, and I would just go back and I would say, right, I have completed and I feel confident with question 1 in the 2019, I'm going to tick that. Okay, and then you'd say, right, I was working on log equations on the 2018 paper. So what you would do is, again, you would find that question and you would tick it as well. So I'm just going back to have a wee look. So it was question number 11 on that. So there we go, log graphs. I'm going to tick that because I've completed it and I feel confident with it. Okay, right, so let's go back and have a wee look at another question. So this one's from the 2017 paper 2, so it's to do with circles. Question 10a, show that the points A, B and C are collinear. Right, so what that means is that if they are collinear, they're all going to lie on the same straight line. Okay, so just as a kind of rough diagram, if I start off with point A, so diagrams are good, but if you look at the diagram below, right, there's A, there's B, and there's C. Okay, so that is what they are asking you to do. Do these 3 points lie on the same straight line? Right, so basically, does the gradient of AB equal the gradient of BC? And they share a common point of B, right? So that's what we'll work out. We'll just say, right, the gradient then of AB is going to be the difference in your y, so 1 plus 2, 1 take away negative 2, okay, so 1 plus 2, and then 2 plus 7. So we end up with 3 over 9, which simplifies down to 1/3. Now, you would then have to actually explicitly find the gradient of BC. Okay, so don't just presume that it's going to work out to be 1/3, right? Although the question implies that it does, right? But you have to show the working. So we have got 6 take away 1 all over 17 take away 2. So we end up with 5 over 15, and that simplifies down to 1/3. Now, common mistake is that people just leave their answer like that, okay, without really doing any explanation, just expecting the marker really to finish the question off for them. You have to explain why that means that they lie on the same straight line. So you would have to say, since the gradient of AB is equal to the gradient of BC, and B is a common point, points A, B, and C are collinear. Okay, so that is part A answered for you. Right, moving on then. Right, so that was part A and that was worth three marks. So we've done that bit. Right, moving on, it says 3 circles with centres A, B and C are drawn inside a circle with centre D as shown. The circles with centres A, B and C have radii RA, RB and RC respectively. So it tells you in the bullet points that RA is root 10, RB is 2 times RA, and the radius of CRC is equal to the radius of A plus the radius of B. right? So what I would probably do first of all is just go through that bullet points and say, right, that is just telling me that RA is root 10. Second bullet point, the radius of B is double that, so that's 2 root 10. And then the radius of C, the third one, well, that's just telling me that I've got 3 root 10, because I'm just adding the radius of A and the radius of B together. Okay? Now, what you're going to end up with, okay, is a line, right? Again, right? So there's A, there's B, and let's say there's C, right? Now, looking at the diagram, right, and there is roughly kind of D there, right? But looking at the diagram, you know that A to B is, so the radius of A and the radius of B added together, so the length of AB is going to be 3 root 10. Now, if we are then having a look at B to C, you can see that B to C is the radius of B plus the radius of C. So the length of that line there is 5 root 10. Okay? So if we are thinking of this as a ratio, right, what that means is that we have got B splitting that line in the ratio 3 to 5 effectively, right? But what we can also do is we can work out the distance between A and C, or we could work out the distance between A and B, or we could work out the distance between B and C, right? And remember that you've done those things in part A, right? So because the gradient of AB is 1/3, it just means that you're simplified, okay, along here is that the difference in your y's for that line there is 3, and that's 1, okay, and the walkway of that one here, because it is, sorry, the walkway was actually 3 along 9. It did simplify down to 1/3. And then the walkway of that next one, okay, so looking at the fraction, was 15 along and 5 up. Okay, so what you want to work out is the centre of D. Okay, so you want to determine the equation of the circle with centre D, right? So what you can work out is that, I've taken too much of that line to be honest, right? So there's my line A, there's my point A, there's my line B, and there's my line D. So we know that the radius of B is 2 root 10, okay? And the line from A to B, okay, must be 3 root 10. All right, so if we are comparing these two triangles, right, so what you've actually got is 5 root 10 along there. So it just means, right, it's going to have the same as the distance between B and C. So it's going to be 15 along from A and 5 up from A. Now, if you know that A is the point, so we go back and have a wee look at that, -7 minus 2, 15 along from that means that D is going to be 8, and the Y value for that is going to be 3. So 8, 3 is your centre for D. Okay, so that is the centre of D. What we have to then work out is what the radius of D is. So the radius of D just goes between B and D, and we've worked out the length of that already. It was 2 root 10. Okay, so that is the radius of circle D. Well, in fact, no, it's not, right? So circle D is actually just this big circle here. So the radius is that full line. Okay, so you've got all of this with another root 10 added on. So it's actually the radius is going to be 6 root 10. So when we come to write the equation of the circle, right, make sure you pick the right one. So it's always this one that we pick when we're making up the equation of a circle, okay, because it's just far easier to use for doing that. We've got x minus 8 all squared, x minus 8 all squared plus y minus 3 all squared. And if you square 6 root 10, you're going to get 36 times 10, which is 360. And that would be your final answer. Okay, right, finally, question number 4 that we're going to look at today is going to be a wave function, and it is taken from the 2016 paper 2. So what we do first of all, good idea to equate this 5 cos x minus 2 sin x, let that equal to the wave function form. Now look at your formula sheet, okay, and make sure you get the correct expansion. So k cos x cos A minus k sin x sin A, okay, and that is mark number 1 for that one. Now, they will be looking very closely to make sure that you've got a k there and a k there, okay, so make sure you don't forget about those. Right, the next bit then is I want to get a value for k cos A. So I'm going to cross out my cos x here, cross out my cos x there, so it's equal to 5. I then want a value for k sin A. So I'm going to cross out a value, my sin x there and my sin x there. Minus k sin A is equal to minus 2, so double negative cancels out, so that's why we get 2. Your value for k is worked out by saying, right, 5 squared is 25, 2 squared is 4, add those together, I get the square root of 29. Okay, now your value for tan just becomes sine over cos, so 2 over 5, and the value of A is just the inverse of tan of 2 divided by 5. So shift tan, 2 divided by 5, and you end up with 21.8. Now just be careful, because if you go back and look at the question, right, the range of values for A is in radians, so we have to divide by 180 and times by your pi button. So to 1 decimal place there, what you should have got was 0.4. So this is us dividing by 180, timesing by pi to get it into radians without a calculator. Okay, so then what we end up with is root 29 of cos x plus 0.4. Okay, so make sure you get the correct expansion. They've asked you to change your degrees into radians. Now, for part B, it says the diagram shows a sketch of part of the graph. Okay, so you should recognise that this bit here is the same as part A. So what we are then going to do is say that, well, this is y equals 10 plus root 29 of cos x plus 0.4. Now, they're asking you to find the x-coordinates of P and Q, so where this meets that straight line, which is 12. So we're just going to take that 10 plus root 29 of cos x plus 0.4, and we're going to let that equal to 12. Okay, so then just rearrange, so we get root 29 of cos x plus 0.4 is going to equal to 2, and then what we end up with is cos x plus 0.4 is equal to 2 over root 29. Now remember your CAS diagram at this point, okay? A lot of people forget about that. Higher, your fraction is positive, so it's positive there and there. Okay, so I'm going to do shift cos of 2 divided by root 29. It's a calculator paper. What I get is 68.2 degrees, and that is for x plus 0.4, and that is equal to 68.2. Now just be careful because, right, I'll explain why in a minute, but 360 take away 68.2, 291.8. Now you've got degrees and you've got radians in the same line, so technically that is not mathematically good to do. Okay, so what we then have to do is rewrite the 68.2 and the 291.8 as radians. So 68.2 divided by 180 times by your pi, and what you get is 1.2 for your first radian value there. 291.8 divided by 180 times by pi, and you get 5.1. And then you're able to take away 0.4 from both of those. So your first x value of xp is 0.8 and xq is going to be 4.7, and that is your final answer. Okay, I hope that you found going over those questions helpful. Okay, another thing that I would like to point out to you is what David Cleland was talking about in his video as well. It's the higher maths, Zeta maths checklist. Okay, there's a link there. Useful if you could maybe print that off, okay, or have it so that you can write on it digitally, and then you can just self-assess on your red, amber, green. Red meaning that you're still finding that really difficult, amber that you're okay, green that you feel really secure in your understanding of those particular things. Okay, it's quite good in the sense that it gives you a wee bit of notes, it gives you some examples, but really the best thing that you can be doing just now is getting stuck into past paper questions. Okay, just a wee word about the formulae sheet. Don't forget to look at that throughout your exam. Okay, you get it for both paper 1 and for paper 2. It's the same formulae sheet. You've got your circle formulas first of all. Okay, so make sure you know when and how to use them. Scalar product stuff is out. Hopefully it won't be in your formulae sheet at all in the exam. The trig formulae, you will need to know how to use it, and the table of standard derivatives. Okay, how do you differentiate your sine and your cos functions? Now, you will probably be used to your formulae sheet already because you've probably been using it a lot in class. The only thing that I'm not sharing with you is the table of standard integrals, because integrating cos and tan are out, so you don't even need to know where that is in your formulae sheet. Okay, so as well as kind of downloading that checklist with the past papers, okay, and the Zeta Maths checklist as well, other things that you can do is make sure that you are revising regularly. Okay, it doesn't matter if you have done the past paper, a specific past paper, a million times. Okay, you could always do it again. Okay, to see if you have quickened in your answering. Okay, use the past paper checklist. Right, make your own copy. Get to know the marking schemes. Okay, because it is going to be important to know where the marks are coming from. Time your solutions. Okay, so if you're doing the question for a third or a fourth or a fifth time, Okay, maybe set the clock, right, just to give you that wee feeling of pressure, right, because you want to get used to feeling pressure, right, so that you don't find it overwhelming on the day of your exam. Read questions carefully. You might have to read them more than once. You might have to go back and read them once you think you've finished a question, okay, just to make sure that you've answered it the way that you were meant to. Practice your presentation. Okay, so what I mean by that is if you know that your working, your solutions, your writing is a wee bit sloppy at times, right? Make a real effort to tidy that up from now until the final exam. Okay, I think that everybody could get a wee bit neater with their presentation. Make sure that what you are writing down as numbers is what you mean to write down. So make sure that we can tell the difference between a 7 and a 4, right? Because you don't want to get marked down just because a marker can't read your writing. Ask questions. So by that, what I mean is speak to your teachers, okay? Speak to your classmates, right? Your peer group, people who have done the higher maths before, okay? Chat to them about questions, because talking through kind of difficulties that you're having in questions sometimes does have the opposite effect. It will help you understand the question. So it takes a question that's challenging and turns it into something that is much easier to answer. Okay, that's about discussing it. And it's also really important to take breaks. Okay, so I hope that you have found this session useful. Download the resources, revise regularly, read questions carefully, practice your presentation, and good luck.